In this video, we'll be looking at the remainder theorem. The remainder theorem specifically says that if a polynomial f of x is divided by a x minus k factor, the remainder, r, equals to the function value at that number. So in other words, for the first example we're going to look at, you're going to have f of x equals to 2x cubed plus 3x squared plus 2x minus 2. And I want to determine what is the remainder if I'm dividing by x plus 2, and what is the remainder if I'm dividing by the factor 2x minus 1. Now there is a slight difference between these two, and what the question really is, the question is, what is f of negative 2? And this question down here is, what is f of 1/2? So again, by doing this and identifying the remainder, again, the statement is, if I'm dividing by this, synthetically I'm dividing by x equals negative 2, and that will tell me what f of negative 2 is. So very cleanly and very carefully, I'm going to go ahead and rewrite this so that I can use the synthetic division on it. 2, 3, 2, negative 2, checking x power 3, 2, 1, and 0. So that means I don't need to have any zeros in here. In here, I'm going to go ahead and write my negative 2. That's my first factor. Again, setting this thing equal to 0 and solving it will provide me x equals negative 2. And then I'm going to go ahead and draw my line. Carry down the first number, multiply. Negative 2 times 2 is negative 4. Add negative 1. Multiply negative 2 times 2 is 2. Add 4. Multiply negative 2 times 4 is negative 8. Add negative 10. So what this tells me is this is the remainder. This is a different function entirely, but if I'm asked what is the remainder, this is the remainder. And then what is the value of f of negative 2 on this function? Well, very clearly, f of negative 2 by the remainder theorem is simply negative 10. So this is a way that we can very quickly and cleanly evaluate what the function value is at a number using synthetic division. Again, if you don't trust this, by all means, take negative 2 and plug it into all the x values and get back a number. But the expectation is when you're told to use the remainder theorem to do this, you need to be able to show this synthetic division. So let's go ahead and show the second one here. Keep in mind, we're still dividing by now 1/2 instead of a negative 2. Secondly, we're using the exact same function, so none of these values are going to change. I'm going to carry down the 2 and multiply. 1/2 times 2 is 1. Add 4. 1/2 times 4 is 2. Add 4. 1/2 times 4 is 2. Add 0. So this is my remainder. Now something very specific comes out because of this remainder. And again, in the previous video we mentioned that if my remainder is a very specific number, something wonderful happens. So let's talk about this for a second here. Again, us dividing by 2x minus 1 tells me that this thing here provides me with a remainder of 0. What does that remainder tell me? Well, that remainder tells me that f of x equals to 2x3 plus 3x2 plus 2x minus 2 has a location at 1/2 where if I plug 1/2 in, I get back a value of 0. Well, what this means is that the 2x minus 1 factor right here is a perfect factor of this polynomial right here. So let me rewrite this in the division algorithm form just so you guys can truly understand what is happening here. The division algorithm form, again, one more time, says 2x cubed plus 3x squared plus 2x minus 2 equals to my divisor, 2x minus 1, times my quotient, 2x. Now keep in mind, when I divided this, this was x cubed originally to start, so when I divided it, it became x squared. So times 2x squared, and then plus 4x plus 4. So what we're trying to say here is plus a remainder of 0, which means if I were to multiply these two things out, I should get exactly this. Now there is a slight issue with this, and that's because of this 2 and because of the way that it's synthetic division. So I'm going to be very clear about this. This division right here, when we divide by 1/2, causes this polynomial to actually change in its nature to be more like this. So in reality, when I divide anything by this or by this, it's going to treat it as though it was like this one right here. Again, when I use synthetic division, it treats it as though it's exactly like this one. So that means that when I've told to divide by this polynomial here, I've actually not divided by that polynomial, but divided by this polynomial. And you'll see very clearly that there's a 2 in this stuff here that I can factor out, multiply it into here, and end up with 2x minus 1 times x squared plus 2x plus 2. But again, the biggest takeaway from this is when my remainder happens to be 0, you'll notice that this x minus 1/2 and this 2x minus 1 happens to factor this polynomial. So this is the first key in being able to identify very cleanly and clearly what the factors of a polynomial are without having to do actual factoring.